right, we'll start our next lesson on 14.4 using definitions of trigonometric functions. We are going to talk about some of the same things as our previous lesson, so I do want to still recall our 6 trig ratios just to kind of jog your memory. We're going to use them in our lesson today, so I want to reference them. So we'll look at sine of an angle theta, cosine of an angle theta, tangent of theta, and then their 3 reciprocal functions. So sine was the y-coordinate over r. Cosine is the x-coordinate over r. And tangent is the y-coordinate over x. All right, we drew a little picture with this to kind of see why those were the ratios that they are based off of our SOHCAHTOA from geometry. All right, eventually we want to just be pretty familiar with this. Then sine reciprocal would be cosecant. So I just flip over r over y. Cosine's reciprocal would be secant. So I change that to r over x. And then cotangent would be the reciprocal of tangent, which would be x over y. So we're going to want to use those ratios today to answer most of our questions that we'll be working on. All right, so we talked about these reciprocal functions. We have what's called reciprocal identities. All right, so I can write sine of theta as 1 over cosecant of theta. That's its reciprocal identity. Okay, so when I'm given the ratio, I just flip that over. But if I'm given this angle or the sine of that angle, I can just create that as a fraction itself. So then cosine of theta can be rewritten as 1 over secant of theta. And then tangent would be rewritten as 1 over cotangent of theta. And then we can do the same thing with the reciprocal functions. So cosecant of theta, we can write as 1 over sine of theta. Means the same thing. Secant of theta, we'd write as 1 over cosine of theta. And then the last one, cotangent of theta, we would rewrite as 1 over tangent of theta. You'll be asked to use these reciprocal identities to kind of help you out or rewrite things as we go into further lessons here. And the higher levels you go into trigonometry, you'll find there are lots and lots of identities of these little facts, these things that are equal. Okay. So let's look at a couple examples of when we would use our reciprocal identities. So we'll look at 2 examples of this. So if I said find cosine of theta, if you were given that secant of theta equals 5/3. Okay, there's not any work to this. It's just the knowledge that if I want cosine and I have secant, well, that's just the reciprocal. So cosine of theta would equal 3 over 5, and that's it. All right, so if I give you another example, and I say find sine of theta, and you are given cosecant of theta as the negative square root of 3. Same concept as what we just did. All right, you are given the reciprocal to sine, and we want sine. The last time I was given a fraction, so I just flipped that over. So I'm going to flip this over. That would technically be over 1. So when I write sine of theta, that would equal a -1 over the square root of 3. All right, but we're not going to leave the square root in the denominator. So I will rationalize that denominator by multiplying the top and bottom by the square root of 3, which I get a negative square root of 3 on top. We talked about this a little bit yesterday, but if I multiply those together, that gives me the perfect square of 9. So when I take the square root of that, that's how I'm left with just 3 in the denominator. So the negative square root of 3 over 3 would be the answer for that problem. So if you're given a radical, it does take more time to find the reciprocal because you will have to rationalize that denominator. Okay. All right. Something else that you'll be asked to do, it's going to ask you for, if you're in a certain quadrant, what's the sign for sine? All right, so when I say sine, I mean positive and negative for that function sine. All right, so we're going to make a little sine, S-I-G-N, sign chart for our quadrants of our trig functions. All right, so I'm going to draw on a coordinate plane here, and I'm going to want to leave enough space so that I can write down something for sine of theta, cosine of theta, and tangent of theta in every single quadrant. So make enough space for that. All right, so we're just going to put a positive or a negative next to each trig function to determine if it would be positive or negative within that quadrant. If you still need to label these, because that's quadrant 1, 2, 3, and quadrant 4. If you don't use Roman numerals, that's fine. But oftentimes when you select it as multiple choice or when it's written as a problem, it's going to be using Roman numerals. So I will just be consistent with your book and the Math Excel program. All right, so when I'm in quadrant 1, I have any point over here, the x coordinate would always be positive, and the y coordinate would always be positive. Okay, when I'm in quadrant 2, my x coordinate is negative and my y coordinate is positive. In quadrant 3, they are both negative. And in quadrant 4, the x is positive, the y is negative. All right, we should already be familiar with that just from graphing points, you know, from our middle school days through high school. All right, but let us use that visual for us. All right, so then we'll go back and we'll look at sine of theta in quadrant 1. So I'm thinking back to sine uses all the way up to our identities, y over r. Okay, so I need to figure out, is the y coordinate positive in that quadrant? Okay, r is always going to be positive no matter what, because r is the only one that's an actual distance within your function. All right, so the y coordinate's positive, r is always positive, so sine's going to be positive. Okay, cosine uses the x coordinate over r, which is also positive. Tangent uses y over x, which they are both positive. All right, so quadrant 1, not very interesting. Everything's positive in that quadrant. All right, the others we got to pay a little bit more attention to. All right, so sine, once again, uses the y-coordinate, which is positive. Cosine uses the x-coordinate, which is now negative. Tangent uses y over x. So if one of them is positive and one of them is negative, that would make tangent negative. Okay? In quadrant 3, both sine and cosine would be negative since the y and the x coordinate are negative. Tangent, however, would be positive because you are taking the y coordinate and dividing by the x coordinate, which if they're both negative, it would make tangent positive. Okay? Sine, remember, is the y coordinate, which is now negative in quadrant 4. Cosine uses the x coordinate, which is positive in quadrant 4. Tangent uses both x and y, so if one is positive and one is negative, that makes tangent negative. Okay, so we're using our knowledge of the coordinate plane, and when your x value is positive, when your y value is positive, and vice versa. All right, and then those trig ratios. So you'll be asked, in quadrant 2, is sine positive or negative? And you just check, positive. Okay, you might be asked about your reciprocal functions as well. So if I ask you about cosecant, all right, you just need to know that cosecant would be the reciprocal for sine. So if I flip over a fraction, it's positive, it's still positive when I flip it over. If I flip over a fraction, it's negative, it's still negative when I flip it over. All right, so you shouldn't have to memorize that by any means, as long as you're familiar with which ones are reciprocal. All right, this is not a chart that you have to memorize necessarily either. You're just understanding the ratios and then where things are located. But it's a nice little visual just to kind of figure out why something would be positive or negative in a certain quadrant. All right, moving on. So you might be asked to determine the signs, SIG and signs, of functions for angles. All right, so you'll be given a particular angle. So if I give you 300 degrees and I want to find the sign for each trig function. Well, we just looked at where the quadrants are at, so I need to figure out where is 300 degrees. So if you need to make a little sketch, or if you already have a visual for where that would be located, great. So that's going to take me to 90 degrees. That'd be 180, 270, 360 goes all the way around. So somewhere in quadrant 4 is going to be 300 degrees. All right, when we first made those sketches last week. All right, so then you can use your chart you just made. You can think about how in quadrant 4, all the x values are positive, all the y values are negative. So it's going to ask you individually in Math Excel, if I gave you sine, will that be positive or negative in this quadrant? Well, sine uses the y-coordinate, so that would be negative. So then you just check the box for negative. All right, then it might ask cosine. Well, cosine is going to be positive because it uses the x-coordinate. All right, then we'll ask you about tangent. Okay, so tangent uses both the x and the y. So since one's positive and one's negative, that would make tangent negative. All right, they're reciprocals. So cosecant would also be negative since sine is negative. Secant would be positive since cosine is positive. And cotangent would be negative since tangent is negative. All right, so it's not a lot of work in the sense of writing things out, but you'll have to answer multiple parts to those questions. But it's either positive or negative. Okay. Let's look at one more example of that, just as a reminder on what a negative angle looks like. It's been a little bit of time since maybe we've graphed a negative angle. All right, so this is my starting location. On my last problem, it was a positive angle, and I went in that direction. I'm going to go in the other direction for a negative angle. Okay, that would be clockwise for a negative angle. All right, so this would be negative 180 to make a straight line. If I went all the way back to the x-axis to get, or the y-axis here, that would be negative 270, so that would be too far. So negative 200 degrees is going to land in the second quadrant. So quadrant 2 would mean my x values are negative and my y values are positive. And then I'll use that to come up with my trig functions for sine, cosine, tangent, and the reciprocals, cosecant, secant, and cotangent. Okay. Sine and cosecant would use the y-coordinate, which is positive. Cosine and secant would use the x-coordinate, which is negative. Tangent and cotangent use both, so that would make these both negative. Since my x value is negative, my y value is positive. Okay. All right, so you have to find where that quadrant would be with those angles. You might be given a situation where you have to identify the quadrant of an angle. All right, so for example, if I told you sine of theta is greater than 0 and tangent of theta is less than 0, you are telling me, is that quadrant 1, 2, 3, or 4? Or is it more than 1? Okay? So in Math Excel, you just click it, right? Not a lot of work to do in there, but there's kind of a lot of work that's happening in your head. You're thinking about, well, sine of theta, this means this needs to be positive to be greater than 0. Tangent would have to be negative. So if I think about that, this is y over r. If r is always positive, that means I need a positive value for my y-coordinate. This is y over x, and I must have a positive y since my y must be positive for sine to be positive. So that means my x must be negative. So what quadrant would have a negative x value but a positive y value? Quadrant 2. There's not necessarily any work to show on something like that. I know I'm not really collecting your work, but just kind of keeping that in mind. There's kind of a lot of things that's happening within your head or a visual. Okay, let's look at another one like that. So number 2, if I say cosine of theta is less than 0 and secant of theta is less than 0, where would that have to be located to make that true? So I'm thinking about cosine's ratio. This would be negative. That would be negative since they're both less than 0. Cosine's ratio is x over r. Secant would be r over x. All right, r is always positive. That's the only one that's a distance. So that means my x value must be negative. All right, so when I think about where x is negative, well, that's in quadrant 2 and quadrant 3. All right, so this satisfies 2 of the quadrants since the reciprocals were both included. Okay, so you might have more than one quadrant, and it might only be one depending on which 2 trig functions you're given for your example. Okay. All right, I want to do a couple more examples here of something else that you would see. So we are going to find sine of theta and tangent of theta if we are given cosine of theta equals negative square root of 3 over 4. And sine of theta is greater than 0. All right, so we don't have to find all of the trig functions, just sine and tangent. If I use the fact that cosine of theta is x over r, and I've been given negative square root of 3 over 4, I should know my x and my r. Okay? If I'm finding sine, I want y over r, so I will need to find y. And then tangent would be y over x, which I already have x, but I'll need to make sure that we find y. All right, so there is one more thing that we're told here, is that sine is positive. So that means my y coordinates must be positive. All right, so it's cluing us into where this is located so that we can keep track of what sine, as in terms of positive and negative sine, it would be for our sine and our tangent. Okay? So since the r is always positive, my x value is negative. So I have a negative x and a positive y, so we're sitting here in quadrant 2. All right. Remember to come up with your x and your y and your r, you're using the Pythagorean theorem. So if I know x is negative square root of 3, I must square that. I'm trying to find y, and that would be equal to my r is 4. And then I'll be able to calculate my y. So if I square the square root, it would just cancel my square root, and I'd square that negative, and it would turn out positive. All right, if I subtract 3, I will take the square root of both sides. So we'll have the square root of 13 for my y value. And we know that that must be positive since my sine must be greater than 0. Okay, so we found sine of theta. We know the y coordinate is square root of 13, and I know r is 4. All right, we're also asked to find tangent of theta. So y goes on top, that's the square root of 13. And x goes on the bottom, which is negative square root of 3. But then I just won't leave the radical in the bottom. So I'll multiply the top and bottom by the square root of 3. So on top, I'll get the square root of 39. The denominator would be, you can put your negative wherever. I'm going to throw it in top right now. That'd be the square root of 9 here in the bottom, which leaves me with 3. Okay. I'm going to do one last example, and then we will be done with this lesson. So similar to kind of what we just did before, we're going to find sine of theta and cosine of theta if we are given tangent of theta equals 4 over 3 and is in quadrant 3. So if I'm looking for sine, I need the y coordinate and r. If I'm looking for cosine, I need the x coordinate and r. I've been given tangent is 4/3, which is our y over our x. All right, so if you're not careful about this last part that was right here given to us, you would tell me that y has to be 4 and x has to be 3. That's not true if it's in quadrant 3, right? Tangent is positive in quadrant 3 because both your x and your y value are negative. All right, so that's something that you will miss. And you'll probably do the whole problem correct, but it's going to say you're wrong in Math Excel because you do not have the positive or the negative technically correct. All right, so my x coordinate is actually -3, and my y coordinate is actually -4. But when I write -4 over -3 for tangent, I never write it like that. I leave that as 4 over 3. All right, so there may be some hidden signs in terms of negative signs if you're not paying attention to where it's located. That's one of the most common errors I will see kids do on their homework and tests on these problems. Okay, so when I go to do sine of theta, I know my y coordinate is -4. I just got to come up with that r now. For cosine, I know my x coordinate is -3. I need to still come up with r, and then I have my answers for what they're asking me for. All right, which I just need to do Pythagorean theorem to come up with that. So -3 squared plus -4 squared is r squared. Maybe you already know this would be a 3, 4, 5 triangle, and you don't even need to do that work. Totally fine. Great. I hope some of you know that to save you some time, but r would be 5. All right, if you missed that was in quadrant 3, you'll still come up with the correct r because it doesn't matter whether I have negatives here or positives there. I'm still going to calculate the same r. It's going to matter if I miss it right here. All right, so be very careful about that. It does matter where it's located. Read all of the parts that are given to you. Pay attention to if this is written as positive or negative. Pay attention to if they tell you where it's located, or if they give you another trig function and say something specific about that. All right, that is it. That is it for our lesson on 14.4. Good luck with your homework.